Well, hello. So I'm going to give you kind of a walkthrough and tutorial on how to use the Blackboard and Real Digital if you don't have a circuit board. So what we're going to do is simulation files. And so we can write Verilog code, and instead of putting it on the board, we'll just simulate it on the computer. So don't worry about doing the very first project. This is just uploading straight onto the Blackboard. So we're going to start with the second tutorial. So this one, we're going to be connecting some switches, which you see here, to an LED. And so to get started on that, we're going to open up Vivado, click Create Project, and then I'm going to just click, we'll call this tutorial 1-2. You can save that anywhere, leave all the defaults. And right here, we're going to specify this part. So you'll just have to memorize this or write it down somewhere. We're going to use this part for every single thing in our class. So click Finish. Okay, so now that's up here. I'm going to click Design Sources, and we'll make a new design source. So create file. We'll name this just LED switch. Doesn't matter what you name it, just something intuitive. Leave all the defaults, and then we'll let that open up. So if I click in here, I'll full screen it so you can see. And I'm going to make my text a little bit bigger just so it's easier to see on the video. And so if you want to do this, it's just going to be inside text editor. And then if I scroll down, fonts will go size 18. Okay, this should be easier to see now. So I'll just remove all these comments. We're not going to need these, and I don't need that timescale either yet. So what we'll do is I'll specify all my inputs and outputs here. So our input's going to be a switch, output's going to be an LED. And then we're simply going to connect the LED to the switch, just like that. And so this is our Verilog done for the tutorial. So now we're going to create a simulation file. So I'll click that and make a new simulation source. And I can name this whatever I'd like. I'm just going to name it LED switch. Well, I'll name it requirement 2 simulation. Okay, so you'll see that we have this new file created. And I'm going to full screen this just so you can see it better. I'll delete all these comments. Then I'll clean this up. So when we have simulations, we have to specify our inputs and our outputs. So our inputs are going to be a switch, and our outputs are going to be an LED, just like this. So registers, those can hold values, so we're going to use those kind of like variables to store the inputs, and these wires can't hold values, but they're good to connect as an output. And we're going to, it's called instantiate our LED switch. Don't worry too much about this for now. All you have to remember is we're basically putting this circuit into this simulation file. So we give it the module name, then any name we want. We can call this like cat, dog, doesn't matter. We're just going to call it circuit under test, just because it's not very many letters and it's descriptive. So we're going to connect the switches together. We'll connect the LEDs together. And that's it. Now we simulate. So we do this in what's called an initial begin block. And so initially, we'll set switch to 0. 10 nanoseconds later, we'll set the switch to 1, and then we'll turn it back to 0, and then we'll wait another 10 and end the simulation. So if I go back to my sources window, you can see right here we have this requirement 2 simulation. This has this little icon right here. This is telling us this is the top simulation. And so if we press run simulation, it will run this right here. And so I'm gonna press that, run behavioral simulation. And this might take a couple seconds to boot up, but in a minute we'll be presented with a new window. So you'll see we have this new tab right here, Untitled 1. If I click that, and then I full screen this, I'm going to press zoom fit so we can see the entire simulation. So you'll see at time 10, we set the switch to 1, and then 10 nanoseconds later, we set it back to 0. And you can see that the value of the switch exactly matches the value of the LED. If we go back, we can change a Verilog code. Let's say we want the switch to be the opposite of LED. We can do that too. So I could go and run the simulation again. It'll ask me to close the first one, and then it will run the second simulation. So if I click Untitled 2 and I full screen this, zoom fit, you'll see that now switch and LED have the opposite value. Okay, let's say we want to make a little bit more complicated circuit. Let's say that let's say we have 3 switches. So switch 3, switch 2, switch 1, and switch 0. And we have some like special key. Let's say that we're building like a safe and we want someone to enter a specific like code to unlock the safe. And maybe the LED will turn on when the safe should be open. So we want to like open the safe when, and let's say we want switch 0 to be a 1 and switch 1 to be a 0 and switch 2 to equal the value of switch 3, whatever that is. So what we could say is the LED is going to have the value of switch is 1 and switch 1 is 0 and the other two equal each other. So I could say switch 2 equals switch 3, for example. Now, let me go back to the simulation file. We got to change some things now. So now we have 4 inputs, not just 1. So now we have 4 switches. The LED is the same. This doesn't have to be updated. And so now we just got to update kind of the logic here. So what we have to do is we have to test all the different input combinations for these switches. And you'll see since we have 4 switches here, there's 2 to the power of 4 combinations, or 16 different combinations we can try. So what we could do is after 10, we could say, okay, we're going to set all of these to 0, 0, 0, 1. And so this would turn on switch 1 and leave the other ones normal. And maybe another 10 seconds, we're going to the next combination. And then after another 10, the next combination, and we could try all of them. So we can go through every single possible combination and test all these. So I'm just going to copy this. And here, just like that, and then we'll finish. So if I run this simulation, look at this window. And so you can see here's our switch 1, switch 0, switch 1, switch 2, switch 3. And this is our LED. If I want, I can change the color of this one. So let's say we want the output to be maybe chocolate. So you can see this LED should turn on when switch 0 is a 1, switch 1 is a 0, and the other two are equal to each other. So you'll see switch 0 is a 1, switch 1 is a 0, and the other two are equal. And the same thing happens right here. We have a 1, a 0, and these two are equal. So this is when the LED turns on. So another way we could have done the simulation is instead of using these binary numbers like this, we could have done something a little more simple. I could have said that switch 3 equals a 0, then switch 2 is a 0, switch 1 is a 0, and switch 0 is a 1, for example. And then I could have copy pasted that. Then for the next step, we would go here. The next step, we could go here, all the way through all 16. So that's another way to do it. This is kind of repetitive, so I'm going to show you how to use a for loop to save some time. So I'm going to define an integer value, and this is just going to be a loop variable. So I'm just going to say for k equals 0, a is less than 16 because 2 to the 4 is 16. So we're going to test every possible combination. And then I'll wrap this in a begin and end. And I'll say that switch at k equals, well, I'll just do this. Let's just do switch equals k. This will work. So we'll do this every n nanoseconds. And so if I run this simulation right here, we should expect a similar result. So if we full screen this, we can see the same thing that we saw last time. So we're going through every single possible input combination, and you'll see the LED turns on when switch 0 is a 1, switch 1 is a 0, and the other two equal each other, just like over here. You'll notice that K shows up too. If you don't want to see that, you can just click that and hit delete. And of course, we can do all the normal things like where we change the signal color, or right here, if we want to display these as decimal numbers as the inputs, 1 to 15, we choose radix and then unsigned decimal, and that will be 1 to 15, well, 0 to 15. Okay, now let's do an example where we have multiple LEDs and multiple switches. So what we could do is we could say that LED 0 goes this maybe switch 0, and LED 1 will be connected to switch 1, LED 2 is connected to switch 2, LED 3 goes to switch 3. So what I'll do is I'm gonna modify the simulation a little bit as well. So instead of going to 16, let's just do this. So we'll say the switch at, so let's do this. We're gonna do switch 0 goes to 1. Then switch 0 goes back to 0. And we'll do this for all the switches, where this is 1, 1, 2, 2, 3, 3. And so if I run this simulation, So notice this red is because we never assigned k a value. I'm just going to get rid of k because we don't need it. If you look at these right here, oh, you'll notice a problem. So you'll see that switch 3, right? Well, switch 0 corresponds here, but we're missing the other LEDs. So if you're missing those, it's because we didn't specify that LEDs were now bigger. So go back and run the simulation again. And you'll see now the switches and the LEDs line up with each other. So when switch 0 turns on, you'll control LED 3. Well, LED 0, switch 1 goes to LED 1, switch 2 goes to LED 3, and switch 3 goes to LED 3. Just like that. In our Verilog, we could simplify this a little bit. So we could say that 3 to 0 goes to 3 to 0 like this. And that would effectively do the exact same thing as last time. So if I run the simulation, we'll have the exact same output as that. So I want to quickly move on to later posts in the project. So, well, before I do that, let's go back to the simulation. You'll see a lot of copy paste. Normally, you're not supposed to write copy paste in code. It's just kind of bad practice. I can do this. So we'll make these the 0, 1, 2, 3 right here. These will be k. So k is less than 4, k equals k plus 1. And if I simulate this, this will be the exact same output as this right here. It's going to run over and over again. Okay, so let's move on. Let's make a new source. This will be kind of how to interact with the 7-segment display. We'll just call this one 7-segment display, like that. Leave everything as normal. And I'll click on this. We'll get rid of all that. And then in here, we'll have our inputs and outputs. So if you go Real Digital and you go to Resources and Schematic, that will download this schematic file right here. So if you scroll through this on page 9, you'll see the 7-segment display, and that has a bunch of anodes and cathodes that control it. So the way it works is that if we put a 0 on this line, this anode, it will turn this PFET on, and current will flow down here into here. And then every cathode that's written to a 0, it will allow the current to flow through here and turn on the LEDs inside of here. So by controlling these anodes and these cathodes, we can control anything that can be displayed on this 7-segment display. And so going back to Vivado, we're going to define, say we're going to control those anodes and cathodes with the switches and the buttons. So let's say we have a bunch of switches and we have some buttons. And then we'll have 6 cathodes. We'll have 4 anodes, and we'll have a decimal point. And so we can just connect these up. We can say that the cathode is going to be controlled by those switches. We can say the decimal point is going to be controlled by this switch, and we can say that the anode will be controlled by the buttons. And it's important to make sure that the left side of this equation, this has a width of 7 because we have 7 things on the bus. So it goes 0, 1, 2, 3, 4, 5, 6. So you can just leave it like this, or you can even paste this if you'd like to. Same thing with the buttons. We could leave them because they're both the same length. or we could place those in there. It's not going to make a difference. So let's make a simulation to just kind of see that we connected these properly. So if we go here and click Add Sources, I'll call this one 7-segment simulation. And we'll do the same thing as last time. So we'll click the simulation. I'm going to keep the time scale because we need that. I'm going to clean this up and do the same thing. So our inputs, I'll just grab these from here. So here's our inputs. These are going to be registers. Just like that. Our outputs, I'll do the same thing. I'll grab these. These are going to be wires. Now we instantiate our 7-segment display. So the module name, and then some the name, and we'll connect the switches to the switches, the buttons to the buttons, cathode to the cathode, the anode to the anode, and the decimal point to the decimal point, just like that. And so we can just go through here, and we could say that in the beginning, all the switches are 0 and all the buttons are 0. And then later we could say switch 0 is 1, switch 0 is back to 0. So then we could go through here and do this for all of them. Of course, we've already seen this before. We can make this code better with an integer. So I can just say for k is 0, k is less than 8. We'll do all 8 switches. K is k plus 1. Copy paste that. And we'll do the same thing for the buttons. So for k is 0, k is less than 4, k equals k plus 1. And then we'll say button goes to 1, goes to 0. And then, of course, when we're done, finish. And now, if we run this simulation, we'll let that run. Sometimes you might get an error message if you try to run a new simulation. Oh, let's see. I actually made a mistake here. So what happened here was, you see this is not, this has switches and LEDs. This is the wrong simulation. So to fix that, I'm going to close this simulation right here. You'll see on a sources window, we have to set this to top. So by setting that one to top, this will now become the new simulation file that we have to run. So let me try that again. I full screen this and I open these up. So you'll see this, the switches correspond to these cathodes nicely. The 7th one goes to the decimal point. And these buttons right here, we set them there. Those correspond to these anodes, just like that. So if you wanted to see these a little easier, I might do this. Now you can see that these buttons go directly to the anodes and the cathodes go directly to the switches, just like that. And then of course, we have this little decimal point, which is controlled by switch 7, just as we thought. Okay, the last part of these is with the challenge, we have some more things we can do. So you'll have to control the RGB LEDs. And so I'm just going to give you kind of a model. So RGB. So the RGB LEDs, there's 2 of them on your circuit board, and each one has 3 small LEDs inside of it, 1 red, 1 green, and 1 blue. And so I'm going to open that up. And so what you'll have to do is control the red, the green, and the blue parts. So our inputs, these can be 3 switches. It's like this. And then our output, we can have, I'll just do this, RGB LED, and this will be this wide as well. And so you have to have some assigned statements to connect the switches to those RGB LEDs. Then once that's done, you'll save that, make a new simulation source. Make sure you don't delete the timescale in the simulation. We need that. And then I'm just going to make sure that I spelled that right. Got 1 nanosecond divided by 1 picosecond. Perfect. And so you'll need some inputs. And so these will be your registers. These will be our switches. And then our output. I'm just going to call this one a little different. I'll just name this one LED. And so the module name. Then we're going to connect the switches to the switches. Then here, I'm going to connect RGB LED to LED. And so when we use the dot, that's talking about the module. So if I split screen this, just like that, you'll see those correspond and these correspond. So we can do an initial begin, then this will be your assignment, is to verify that the switches and the RGB LEDs are connected as you expect. And the same thing for the second challenge. So when you're done with each part, so I recommend every requirement will have its own simulation. So you'll have a simulation 2, a simulation 3, a simulation 4, simulation 5 for the first requirements. Then you'll have a simulation for each of the challenges. And so when you're done, simulate your file and send me a screenshot of the waveforms showing me that you got the simulation to run. So with that, I'll leave a Discord and my email with you. If you have any questions, just let me know and I'll try to help you. All right.